All right, here we go. Welcome to the practice problems. How about it? How about it? How about it? Let's talk to it. Here we go. What a day today. All right, identifying characteristics of a parabola. First characteristic we identify is our vertex. Remember, our vertex is either our lowest or highest point on our graph. It's when I'm going down and then start to repeat my values again. Okay, so the vertex here is our lowest point. Our lowest point is 6, 4. Okay, is this vertex a minimum or maximum value? Well, I just said it was the lowest point, so it has to be a minimum. The axis of symmetry. The axis of symmetry, remember, is that line that goes down the middle of our parabola. Okay, our parabola reflects over our axis of symmetry. It's always going to be x equals whatever the x value of our vertex is. So x equals 6 in this case. X-intercept or intercepts. In this case, we have 2. They're pretty nicely marked here for you. Hopefully you can see that. That's 4 and that's 8. So always remember, write your x-intercepts as ordered pairs. 4, 0 and 8, 0. Okay. Y-intercept. The y-intercept is off the graph, so I can't really see it. So I'm going to write N-A for this one. Domain. Remember, domain is all of your possible x values. All right, remember domain, we will read from left to right. Okay, in this case, there you can assume that there are arrows here, arrows and arrows. So my domain is actually going to be negative infinity to infinity for all real numbers. Okay, my range is our y values. We read that from bottom to top. Okay, so if I have a minimum value here, my range, the lowest possible value for y, that should be this should be negative 4. Sorry. All right, our lowest possible value for y is negative 4, and then our highest possible value for y. Well, this graph goes off to infinity, so I can't see it. So my range is going to be from negative 4, and I'm going to include negative 4 to infinity, and I don't include infinity. So it's a bracket around negative 4 and parentheses around infinity. Okay, let's look at number 2. All right, again, we have our vertex is our lowest possible value. It's 0, -1. So this is a minimum. Our axis of symmetry here is always x equals the x value of our vertex, so 0. Our intercepts are nice for us. -1 and 1, so -1, 0. And 1, 0. Our y-intercept. Well, we can see our y-intercept here. Our y-intercept also happens to be our vertex. So 0, -1. Always write your y-intercept as an ordered pair. A lot of times people make the mistake of just writing -1 or writing -1, 1 here for our x-intercepts. Make sure you're writing ordered pairs, expressing them as ordered pairs. Our domain again is going to be negative infinity to infinity. Will it always be like this? I do not like to use the word always because, at some point you're going to find a case where it doesn't work, but I would like to use it here. Or I could use it here. Maybe, potentially, will always be that domain, yes. Okay, but don't get in the habit of using the word always. I don't like it. It's not my favorite. Range. Remember range, our lowest possible value for y, read it from bottom to top. Our lowest possible value for y is -1. Remember, we're looking at our y values here. Our highest possible value we can't see since our graph goes off to infinity. So it's going to be including the -1 to infinity. Let's keep going. We're cruising. All right, number 3. Okay, the vertex here is right here, this point. It's -4, 0. This is a minimum value. X equals -4. Our x-intercept is also our vertex, -4, 0. I can't, unfortunately, see my y-intercept, so I'm going to write NA. Our domain, you can assume that there are arrows. We can assume there are arrows here. All right, so our domain, read left to right. It's our x values. That's going to be negative infinity. That's a parentheses to infinity. Our range is our y values. Our lowest possible value for y here is 0. And our highest possible value we cannot see, so infinity. Now the range will change always. Okay, I don't like saying always. It'll always change though when we're doing parabolas. All right, but what will determine whether or not these are flipped is if I have a maximum. So let's look at the next one. My vertex here is there. All right, it's 4, 0. It's my highest possible point, which makes this a maximum. Okay. My axis of symmetry is x equals 4. Remember, our axis of symmetry comes from here, the x value of our vertex. Our x-intercept, or intercepts, this one's 1 intercept, is 4, 0. Can't see my y-intercept, so I'm going to write NA again. Domain, left to right, is still negative infinity to infinity. Our range now is a little bit different. So remember, we write our lowest possible value first. Well, I can't see my lowest possible value for y since these arrows go off towards infinity. So my lowest possible value for y is negative infinity. My highest possible value for y, the largest, is the highest point of my graph, which makes this a maximum. The highest possible value for y is 0. And I'm going to bracket that 0. Here we go. 1, 2, 3, 4, 5. Number 5. Our vertex is right here for us. It's pretty nice. It's neat. It's 3, negative 2. Is this a minimum or maximum? Well, it's the highest point of our graph, so it's a maximum. Axis of symmetry. Excuse me. Axis of symmetry. Well, axis of symmetry always comes from the x value of your vertex. So it's x equals 3. Our x-intercepts, well, it looks like since this is opening down, all right, this is opening down, and our vertex is below the x-axis, there are no x-intercepts. What? That's weird. What? That's weird. I can't see this again. Holy buckets. How about one of you can see? That'd be great. No kidding. My bad. What's our domain? Our domain, well, our domain is from left to right. Our domain is going to be negative infinity to infinity. This is a maximum. All right. So our lowest possible value for y I cannot see since these go off to negative infinity. So my range is going to be from negative infinity. That's my lowest possible value. Since this is a maximum, well, the maximum value of y is negative 2. And I'm going to make that a bracket. Yo, that's sick. All right, let's look at the last one, number 6, pick up sticks. I'm ready. Are you ready? I'm so stoked. Can you tell? Can you hear it in my voice? I'm excited. All right. So our vertex is the highest possible point, 2, 4, which makes this a maximum. Axis of symmetry always matches your x value of your vertex, x equals 2. X-intercepts, well, there's 2 nice ones here. There's one at 0, 0. And here's a nice one at 4, 0. Our y-intercept is actually one of our x-intercepts, and that's okay. Like, it's possible. Obviously, it's possible since it just happened. Hello. 0, 0. Wow. Our domain... Our domain is negative infinity. This is what happens when you make a bunch of videos in one day. You just start like screaming nonsense. Negative infinity to infinity. Our range, since this is a maximum, it's going to look similar to this. All right. Our lowest possible value for y you cannot see, so that's negative infinity. Our maximum value for y, our maximum value here is 4. So our highest possible value for y is 4, and I'm going to bracket that puppy. All right, those are today's practice problems. Hopefully that helped. If they did not, come find one of us. All right.